So in the previous video, we have discussed about the geophysical methods. In that, we have discussed about gravity, magnetic, resistivity, seismic, and logging techniques. These are all used for finding different kind of material buried inside the earth, and also to study about the earth layers. So in this video, we'll be discussing about the gravity methods, and this is an introduction, so you will be able to understand the basic concepts of gravity. As we all know, Earth contains many layers, and these layers are all uneven with reference to the location. Some places you may have hill terrain, and some places you may have valleys, and some places you may have rivers and channels and all. So this is topographically an up and down areas, and when it comes to the gravity method, we are discussing about the gravitation force at each point, like this in the valleys and in the hill or the mountain places. So now we'll simply go for the concept. uh, in earth, if we have any kind of a buried object, something like a mineral or a pipeline or some groundwater, we have to find the gravitational value here, and then we'll determine what it is. This is because the gravitational methods are usually based on the gravitational attraction between the masses of the buried things. So if we take a location for gravitation study, then we will see a change in the gravity field in a place where you have a buried object. So example, you see this is the plain area where you don't have any buried object. So if you take the gravitational value here in this way, it will be all same almost, because there are no buried objects, and this is all a homogeneous layer. But when it comes to this kind of location where you have a buried object, the gravitational attraction here will be different, because the mass is external when compared to the other layers. See here, the layer is completely normal and there are no external bodies. So everything you get is a regular pattern of graph like this, the gravity values. But when it comes to here, the mass of this object is different from the mass of this object, this layer. So this will definitely give you a different value of gravity than this. So when you are taking a gravity survey, till here everything will be fine. But when you go for a foreign body or a buried object, the gravity value will change. It may go up or down, depends on the type of body that is buried inside the ground. This change in the gravity or the deviation, we take it as gravitation, and this is what is basic thing needed for the gravity survey. So we generally use pendulums for finding the gravity changes. When you go to a particular area where there is nothing buried, you will have a very less oscillation in the pendulum. But when you go for some place where there is a buried object, you may find some difference in the oscillation of the pendulum. This is a traditional method used many years ago. Now, the recent instruments are gravity meters, which will be showing in few time. So the gravity meters, when you keep the gravity meter here, that will give you some reading based on the distance you are traveling, like this distance you are traveling, and the change in the gravity value. So we plot a graph like the distance, and then the change in the gravity in the y-axis, then we will see a graph up or down. So this indicates there is some kind of a object that is being buried inside the earth. So this influence will be almost around the body and inside the body also. So when we are conducting a survey, we will be starting from the point where we find the deflection in the gravity meter, and from there we keep on doing small intervals of reading to get better values. So let us discuss about why we choose gravity methods. So in the gravity methods, usually what happens, Earth is the only source, direct source for the gravity values. So you don't have to take any other electrical source or power source to find the gravities. Just go to a place, keep the instrument, and the particular gravity reading will be shown directly. And this is used for finding the oil and gas, minerals, groundwater, and other important resources also. And this is not only about the buried objects, it will also tell you about the geological structures like the faults or folds and even the tectonic movement, what is happening inside the earth, you can find out using these gravity methods. So these gravity methods are generally used for almost all kind of studies in the crest, the upper mantle also, and the geophysical investigations for mapping of the sedimentary basins also you can use this gravity method, and to find the buried channels, holes, cavities for limestone also you can use this gravity method. And in mineral industries, people are using this gravity method to find the coal, lignite, and sulfide, manganese, and barite also. Nowadays, this particular gravity method has come into use for the groundwater surveys also. So let us discuss about the basic principle of gravity method. So coming to the basic principle of gravity method, we know at a particular place there is a gravity pull. So even if you go onto the top of a hill or you go into the valley, there is a gravitational field. But the main principle of this gravity method is to measure the variation. So here you may have a particular value of gravity, but somewhere you may have a lower value or somewhere you have a higher value. So this variation studying is the basic principle of gravity method, and this is because of the geological features, something that is buried inside this subsurface of the earth. So when it comes to the Newton's law, he stated that every mass in the universe will attract each other. So if you take two bodies like this, so they attract each other. But the force of attraction will depend on the masses of the two bodies, and also the inversely proportional to the distance between them. From here, this is the center of gravity of this, and this is the center of gravity of this body. So the force will be inversely proportional to the center of gravity, distance between the center of gravities, and it is directly proportional to the product of the masses. Example, this is M1, and M1 you have here, and this is M2. So when you take this force, we get this M1 into M2 by the distance between the two center of gravities. So that is square. So when we are measuring the gravity values of a location, we use the gravitation acceleration instead of gravity force. Here we need to understand one more term, that is gravitation acceleration. When we consider one body that is falling from the top, just like a fruit or something, so when it is on the top, it will fall slowly, but when it reaches the ground, the speed increases. This increase in speed is called as acceleration. And in the gravity method, here the gravitation is the increase in the speed of a body under the influence of gravity. So as the speed is being increased because of the gravity, this is called as gravitational acceleration. So we again take an example. When you take the fruit that is falling from the tree, it reaches the ground and it becomes smashed because of the influence of gravity and the increase in speed. We all know about the speed. It is just simply the distance traveled by any object and also divided by the time it take from top to reach the floor. This is generally compared in units as kilometers per hour. With this speed is changing with time, so we call it as acceleration. When the speed is increasing when it reaching the floor, it is positive acceleration. And at the same time, when the acceleration is going decreasing when coming down, that is negative acceleration, and we take this unit as meters per second square. So the variation in the acceleration is used in the gravity surface. In general, at the mean sea level, the acceleration is 9.8 meters per second. And due to the presence of any subsurface bodies like this, the value will change from 9.8 to something more or less. That is because here at the sea floor, you have a constant value. But when you have a buried object, this value may go down to 9.8, or sometimes it may go above 9.8. This is the reference value. So if you convert this into gals, then I can approximately say it is uh, it is 98,000 milligals. That is the reference value. So how do we use gravitational acceleration in surveying? This is what we need to know. We know that density is a mass per unit volume. So in a field, if the subsurface may or may not be filled with any material, here it is not filled with any material, but here it is filled with material. The place where there are no subsurface materials will have different density. So here the density will be like normal, but when it comes to the top of the subsurface body, then it may go up or down depending on the density. So when we take any mineral body, for example, then the density of the mineral body is more than the soil around it. So here you don't have any mineral, so the soil density will be different. But here you have mineral, so this is an added value. So this density will increase. So then this shows that there is some kind of a material here. So we need to focus on this particular area, and then we must do a very detailed survey for gravity. So when we are using a gravity meter, the acceleration, the gravity of acceleration or the gravitational acceleration changes with the surface body. And this value is like plotted on x and y axis. And let us discuss about how the gravity values are made. In general, we have three kinds of gravity methods. That is one is for the measurement of a falling body, which means we drop a object from some distance and we measure the distance traveled by the object and the time it took. From that, we'll get the acceleration. This is one of the method for identifying the base stations or some absolute gravity places. We'll discuss about absolute relativity in the next chapters. So the second kind of measurement is done using the pendulums. So the oscillation time used for estimating the gravitational acceleration. Using this also we can identify the base zones, and that we'll discuss in the next coming videos. So when a mass is suspended on a spring and it is placed over this particular area, like if you take an example, the so this is a particular spring and the mass is here. So when the mass is hanged on a particular layer, there is no more movement in the spring. But when there is some kind of subsurface body, then there is definitely an attraction and there is a change in the length of the spring. Either it extends or it compresses. So this is the basic principle of a gravity meter. So the gravity meters we'll discuss in the coming videos. So the modern gravity meters are used to find the relative gravity values in a particular place. So they have a spring balance with known mass. This mass is known already and it is placed on different places on the earth like this. The place where you have some subsurface body, the extension of the spring will be stretched down. So this will indicate there is a change in the gravitation attraction. So this is the basic thing about the gravitational method survey, the gravitational method introduction, and in the coming videos we'll discuss about the survey techniques for gravity, and also more details about the instrumentation and how they work.